One of the first things you must think about when you are deciding to do an activity is what you're going to change, measure and control, because you're trying to tell the reader that you think something is going to happen and you can show this is happening by the trends and data that you collect based upon what you choose to change, measure and control. Now, don't forget, we must think about the control ones in particular, and we should only ever change one thing at a time. Otherwise, we can't be sure what is causing the change. Now, this is called a fair test. A fair test in science terms is the fact that you get there and you change one thing to see its effect on something you are measuring. So while you're doing that, if you have multiple things, you can never ever be sure of which one caused your measurement to change. So that's why you must do it. Now you should tell me that you are sure it's a fair test, because doesn't that make it more reliable, more trustworthy? Doesn't it fill the reader with more confidence that they could use that material? So this is why you should be bringing in words like reliable. Now, what we're trying to do is we're trying to see if that cause or that thing we cause the change is causing an effect to happen. So it's also going to cause a change in something else. Now, sometimes it doesn't. That's also good to know, because we need to know if this could cause that change, and our result might either confirm it does or just say to us, no, there's no thing that we can say that is linked with that at all. More about that when we get to a bit of analysis work. All right, this is important. This is what I said to you about fair testing. The change must be caused by what we chose to change. In other words, I changed the height I dropped a ball from, and that changed the force on the ground. Okay, that's good if that was the only thing I changed. If I change multiple things, that is not going to help my decision making and not make my results very reliable. Now, we actually call the thing we're going to change the independent variable. And you in your report must tell me about it, and must also tell me how you changed it. What did you do? Did you change it a little bit each time, or did you change big chunks each time, or how far did you change? Did you change it 0 to 100 or whatever? So you've got to tell me these things. And you've got to do the same thing with the measurement. You've got to tell me what you're measuring and how you measured it. So details are important, and often they're overlooked. But it doesn't help me decide if I don't know what you're doing. Remember, I said in a couple of videos ago that what we're trying to do to check your results, we must have reproducibility. In other words, I should be able to do your experiment to check your results. So I need to know as much detail as possible. So I really need to know what you're doing with your independent variable and how you're changing it, how big the changes are each time, how wide an area I'm looking at, how many times I'm going to change it, all these things. And then you should tell me about my dependent variable. In other words, what I'm going to measure. How I'm going to measure it is super important. Some measurement is not quite as accurate or not quite as precise. In other words, I won't get the precision I need to make really, really good results. Now, another really important thing for you to tell me is what things you are going to keep the same. Right? So you tell me about the things you're going to keep the same. Normally we ask for 3 or 4. 3 is fine. And often it will be some piece of equipment. For example, I might be doing a chemistry experiment, so I'm using a 100 cm cubed beaker in every part of my experiment. Why not tell the person that? That is not going to have any effect on what I control and change or what I measure. Now, tell me also about controlling. If you're just saying over here, again with our beaker idea, you say, oh, I'm using a beaker. Well, in a normal lab, there might be 6 or 7 different sizes of beaker, and each of those could affect our results. So we should keep the same size. If we're using chemicals, maybe we could use the same volume if they're liquids or the same masses if they're solids. Things like this are really important. And you can sort of mention this is going, don't just say it's going to be, and the test is not going to be fair anymore. Just say, well, it's going to affect our results, the fact that we are changing more than one thing. So we are unsure about if what you're measuring changes, then it was actually caused by what you think it was caused by. There is less proof and less reliability in your data. So please make sure you do it properly.